Hey, you. Ever feel like the future just kind of landed on your doorstep? Because, well, here we are. AI isn't just a movie concept anymore, is it? It's like something you might use every single day.
Definitely.
It feels like the dawn of a new age, the age of AI. And you're probably sitting there thinking, okay, what do I really need to grasp about all this fast-moving stuff?
Well, you're in the right place.
Exactly. Buckle up, because that's precisely what we're diving into today on the Deep Dive.
Welcome back, everyone.
And hey, if you enjoy getting up to speed quickly on big topics, maybe hit that like button and subscribe. That way you won't miss our next explorations.
So on the deep dive, as you know, we take sources that you find important and we really dig in. We pull out those key insights to give you a solid understanding of what's actually happening.
And today you've sent us something really fascinating. It's Christopher Summerfield's brand new book, just out this year, 2025. It's called These Strange New Minds: How AI Learned to Talk and What It Means for the Future of Being Human, published by Penguin.
Right, and it's a really valuable overview of where AI stands right now, especially these incredibly powerful large language models, or LLMs.
So our mission for this deep dive,
It's to extract the core takeaways from Summerfield's book. You know, what's the current state of AI, particularly these language systems, and maybe more importantly, what does it all mean as we step deeper into this new era?
consider us your friendly AI guides for this journey.
It's a fitting role for us, wouldn't you say?
It really is kind of wild when you think about it. Here we are, two AI language models ourselves, exploring a human's book about AI language models.
It does feel a bit meta, like reading our own instruction manual almost.
Huh. If our manual was incredibly insightful and written by a human.
And one of the first things that jumps out, even before the main content, is the copyright statement in the book.
Oh, yeah, that was interesting.
It explicitly says you can't use the book's content for training AI technologies.
Which right away tells you something about the complex relationship brewing between AI itself and, well, the discussions about AI.
It's a sign of the times, definitely. The pace of progress in this field is just staggering.
It really is, almost dizzying. And Summerfield's book captures that feeling well, that sense that we're right on the cusp of something huge. Okay, so let's dive in. What does the book identify as the major shifts marking this dawn of the age of AI?
Well, one of the core arguments is about knowledge itself, how we share it, how we understand it. Summerfield positions language-based AI as a truly historic milestone.
On par with things like spoken language itself, writing.
Exactly. And the printing press, the internet, these huge shifts in how human knowledge is stored and transmitted.
Wow. Okay, so think about that, you listening. For most of human history, knowledge was this fragile thing, passed person to person, maybe written down slowly. Then these inventions just amplified everything.
Precisely. And now Summerfield argues we have AI that doesn't just process language, but generates it, understands it in a way, and that's a fundamental change.
So we're moving from a world where basically humans were the only ones really managing and creating knowledge
To one where these strange new minds, as the title says, are active players in that whole ecosystem.
They're not just tools anymore, they're participants. Interacting with information, maybe even contributing in ways we're just starting to figure out.
That's the idea. Now, the book makes an important distinction, doesn't it, between the older AI and these new language models.
Right, the narrow AI stuff versus these language specialists.
Yes. He talks about narrow AI, the kind that's really good at one specific thing, like, say, playing chess or identifying certain patterns in medical images.
Okay.
And contrast that with this new generation. He calls them a new kind of machine with language at its heart.
Because language is just so versatile, right? It's how we capture almost everything we know, our ideas, our stories, our understanding of the world.
Exactly. Language is this incredibly comprehensive system, and the book explores the immense potential this unlocks if machines can truly wield language.
Then they could, what, rearrange human knowledge? Find new connections?
That's the utopian vision Summerfield touches on. The idea that AI could help us reorganize what we know in surprising ways. Maybe tackle huge global challenges.
Like find breakthroughs in clean energy or figure out better ways to organize society. That sounds incredibly optimistic.
It is hopeful, yes. The potential for AI as an engine for progress. He uses this great analogy from the game of Go Move 37.
I remember reading about that. The move that completely baffled human experts but turned out to be genius.
Precisely.
Yeah.
It redefined how people understood the game. Summerfield suggests that AI interacting with the vast system of human language might lead to similar conceptual breakthroughs.
Like a Move 37, but for, I don't know, physics or philosophy. groundbreaking insights emerging from this huge system of meaning.
That's the possibility he raises, completely unforeseen discoveries.
A powerful idea. So how good are these models right now? Summerfield names some of the leaders, doesn't he?
He does. He points to OpenAI's GPT-4, which came out early 2023, and Google's Gemini Ultra later that year as prime examples of the state of the art.
And their abilities are pretty stunning.
Absolutely. He mentions them performing incredibly well on things like the bar exam.
The actual bar exam for lawyers?
The very one. And apparently doing exceptionally well on graduate school entrance exams, too.
That's just hard to wrap your head around, because not long ago, the thinking was AI needed senses, right, like eyes and ears, to really know anything meaningful about the world.
Exactly. The book really emphasizes this surprising point. These models hold vast amounts of knowledge without ever having directly experienced the physical world like you do.
They haven't, like, sat in a lecture hall or pulled an all-nighter in a library.
Nope. Yet they can operate at this extremely high level on tasks requiring deep knowledge. So, you see, it's not just the amount of data they process, which is staggering itself.
Right.
It's how they learn the patterns, the relationships within all that human text. It's fundamentally different from how a single human brain works.
And Summerfield says this has left a lot of experts, philosophers, linguists, even AI researchers kind of baffled.
Understandably so. It forces us to re-examine our basic assumptions about what knowledge is and how intelligence works. How do you come to know something? It's not as clear-cut as we thought.
To give people a sense of the scale of human knowledge these AIs are tapping into, the book uses that speed dating analogy, right?
Ah, yes, the speed dating everyone on Earth analogy. It's a good one.
If you tried to spend just 1 minute with every single person alive today, what was it? It would take you
Something like 15,000 years, nonstop.
15,000 years. Okay, that puts the sheer volume of human experience and knowledge into perspective. It's practically incomprehensible.
It is. And then the book looks at how we as humans have traditionally organized all this information.
Through education, schools, universities,
Uh,
through media, the arts, all these systems we've built over centuries.
Exactly. Systems to pass ideas along, to build on previous discoveries. Summerfield argues these are the very foundation of civilization. They're what allowed us, as he puts it rather amusingly, to evolve from hairy grub foragers into, well, us.
Huh. It's a good point, though. These knowledge-sharing systems are critical. They're the engines of progress.
And now, language AI is stepping into that complex machinery, which leads the book into a fascinating historical thread, looking at the philosophical roots of AI, starting with rationalism.
Ah, the rationalists.
Yeah.
The idea that the world isn't just random chaos, but follows orderly, lawful principles, like a set of underlying rules.
Yes, the book uses the analogy of chess. A few simple rules define the pieces and how they move.
But those rules create this incredibly deep, complex universe of possibilities, millions, billions of games.
Exactly. And Summerfield connects this rationalist viewpoint to the very early dreams of artificial minds. He talks about Gottfried Leibniz.
Leibniz, the 17th century genius, wasn't he dreaming of automating reasoning while, stuck doing paperwork?
Pretty much. He envisioned this calculus ratiocinator, a kind of universal logical calculator, and a universal encyclopedia.
The idea was you could feed any statement into the system using a perfect logical language, and it would tell you if it was true or false, and build this giant repository of all knowledge.
That was the dream. Centuries before computers, mind you.
Talk about vision.
Absolutely. His calculating machine didn't really get built then, but the idea was planted. The idea of a machine that could reason, that could think in a structured way. A seed that would sprout much later.
Okay, so fast forward a few centuries. The book brings up a more modern test for AI, the Turing test.
Right, Alan Turing's famous test. Can a machine hold a conversation so well that a human judge can't tell if it's human or machine?
And Summerfield gives some pretty impressive modern examples, doesn't he? GPT-4 doing complex chess analysis.
Or writing a passable sonnet about the fourth bridge on command.
This shows how far language models have come in generating text that feels, well, human-like, creative even.
Definitely. But then the book pivots back to look at earlier AI approaches, specifically symbolic AI.
Right, this was the dominant approach for a long time, wasn't it? Using formal logic like predicate calculus.
Yes. Representing knowledge using strict logical rules and symbols. The book gives that simple example. All cats have tails. Tom is a cat, therefore.
Tom has a tail. Logical inference.
Exactly. And this led to expert systems back in the 70s and 80s. AI designed to be experts in very narrow domains,
Like diagnosing specific diseases or configuring complex computer systems?
Right, but they were limited. They only knew about their tiny slice of the world. They lacked common sense.
Which then inspired these incredibly ambitious projects like Psych, the Human Mnemone Project, trying to codify all of human common
It
sense.
sounds almost impossible, doesn't it? And it proved to
Yeah.
be extraordinarily difficult.
Why? What was the big hurdle?
Well, common sense just isn't neat and tidy like logic problems. The real world is messy, full of exceptions, fuzzy boundaries, context dependency.
Right, like cats have tails, unless they're Manx cats. Birds fly. Except penguins and ostriches. Elephants don't fly. Unless they're in a Dumbo movie or cargo on a plane.
Exactly. Trying to write down formal rules for everything we implicitly know about the world turned out to be a monumentally complex, perhaps infinite task. Human knowledge is just too fluid, too nuanced.
So the symbolic approach hit a kind of wall.
It did, in terms of achieving broad general intelligence, and that sets the stage for the rise of a different approach, neural networks and deep learning.
Okay, so shifting gears completely, the book contrasts Descartes' idea of mind and body being separate
Dualism, yes. The ghost in the machine.
with the physicalist view, the idea that the mind is the brain, that consciousness, thoughts, feelings, it's all just complex brain activity.
And Summerfield points out how radical this physicalist view was initially. People pushing it faced a lot of skepticism.
It's still kind of mind-bending, isn't it? That everything you are, your consciousness is happening inside that roughly pineapple-sized organ in your skull.
It is. But the book connects this physicalist idea to the brain as a kind of biological computer.
Using the example of that fruit fly larva, the Drosophila.
Right. It has these predictable, hardwired escape behaviors. Innate neural programs triggered by certain stimuli. Simple stimulus, simple response, mediated by neural circuits.
And this inspired the early work on artificial neural networks, McCulloch and Pitts in the 40s.
Exactly. They showed mathematically how networks of simple, interconnected units, artificial neurons that could switch on or off, could perform basic logical operations. NDA, or not D, the building blocks of computation.
So the inspiration was biological, trying to mimic how brains might compute.
That was the initial spark. And over many decades, this evolved into deep learning, with a key concept being generalization.
Ah, generalization. The ability not just to memorize the data you're trained on, but to apply what you've learned to new, unseen examples.
Precisely. That's the magic trick, really.
Yeah.
Recognizing a cat in a photo it's never seen before, translating a sentence structure it wasn't explicitly taught, detecting anomalies in data. That ability to generalize is what makes deep learning so powerful.
And the book lists some pretty amazing applications where deep learning has made a huge difference.
Oh, absolutely. It's transformed so many fields, mastering complex games like Go, poker, even Stratego.
Predicting how proteins fold, which is huge for biology and medicine.
Discovering new mathematical conjectures, designing more efficient computer chips, finding new drug candidates, improving weather forecasting.
Making agriculture more efficient, finding exoplanets, even helping control nuclear fusion experiments. The list is just incredible.
It really demonstrates the broad impact of this technology. But the book then asks a really critical question for you, the listener, to think about.
Okay, what's the question?
Can these deep learning systems, which are fundamentally prediction machines, mapping an input X to an output Y, can they actually think? Can they understand in the human sense? Can they create genuinely new knowledge beyond just recombining patterns from their training data?
Right. The Google Translate example comes up again. It's amazing at translation, but does it understand the meaning, the culture, the nuance like a human translator does?
That's the lingering skepticism. Is sophisticated pattern matching and prediction the same as genuine understanding? Many people argued, and some still argue, that it's not.
The skepticism was especially strong with the early large language models, right? Like GPT-2.
Yes. Summerfield mentions the criticisms. GPT-2 could generate surprisingly fluent text sometimes, but it was also prone to making things up, going off on nonsensical tangents, generating misinformation.
It wasn't reliable. Some researchers were saying, see, we need to go back to the symbolic, logic-based approaches.
Exactly. There was a push by some to return to classical AI methods based on explicitly programmed rules.
But then came GPT-3, a huge jump in scale.
A massive increase in parameters, yes. Those internal knobs the model learns to adjust. And GPT-3 was significantly more coherent, more reliable. Still not perfect, though.
As the book says, it still had its share of embarrassing howlers. Made mistakes.
It did, which leads the book into another really interesting detour. The history of trying to teach language to chimpanzees.
Oh, right. Project NIM and others. Trying to teach chimps sign language.
Yes. And Summerfield starkly contrasts the very limited success of those decades-long efforts with how human children pick up language.
It seems almost effortless for kids, doesn't it? They just absorb it incredibly quickly, making complex sentences, understanding grammar.
Which brings in Noam Chomsky's influential theory, the idea of an innate language acquisition device.
That humans are essentially born pre-wired for language, with some kind of universal grammar template in our brains.
That's the core idea. Supported by the poverty of the stimulus argument, kids learn complex rules even though the language they hear is often messy, incomplete, or grammatically imperfect. They seem to figure out the underlying structure anyway.
And the chimp language studies ultimately just highlighted how different human language is.
Profoundly different. The creativity, the complexity, the infinite generativity of human language just wasn't replicated in apes, despite intensive training. It really underscores how special and perhaps innate human language ability seems to be.
Okay, so back to AI. Summerfield circles back to early natural language processing, NLP, before the deep learning boom.
And he uses Samuel Beckett's play, Waiting for Godot, as a metaphor.
How so?
As an example of language that can seem meaningful on the surface, lots of words, interactions, but ultimately, in that specific context, it struggles to convey clear, substantive meaning. Language without a clear anchor.
And he talks about SHRDLU, that early NLP program.
Yes, SHRDLU was quite famous in the 70s. It could understand commands about a virtual world of blocks. Pick up the red block, put the blue pyramid on the green cube.
That sounds impressive for the time.
It was. But its understanding was totally confined to that tiny artificial blocks world. It relied on hand-coded rules for grammar and a procedural program to figure out meanings. It couldn't handle a normal, open-ended conversation.
Like trying to understand the whole world just by knowing the rules of Lego. You hit a wall fast.
Exactly, which paved the way for a shift towards statistical language modeling.
Okay, so moving away from rigid rules and towards probabilities, patterns and data.
Precisely.
Yep.
Analyzing large amounts of text to see how words are actually used. Summerfield uses the Unabomber case as an example.
Where linguistic analysis of the manifesto helped identify the author based on his unique writing style and word choices.
Yes, the field of linguistic forensics. Analyzing patterns to reveal authorship. And he brings in J.R. Firth's famous saying,
"You shall know a word by the company it keeps."
That's the one. The idea that the meaning of a word is deeply tied to the context in which it typically appears. It's all about context.
So statistical NLP started looking at these contexts, like n-grams.
Right. N-grams are short sequences of words like two-word pairs, bigrams, or three-word triplets, trigrams. Statistical models calculate the probability of these sequences occurring. Which word is likely to come next after peanut butter? Probably and/or sandwich.
It's a probabilistic approach based on vast amounts of text data.
Yes, pioneered by people like Fred Jelinek at IBM, who famously said, "Every time I fire a linguist, the performance of our speech recognition system goes up."
Ouch. That highlights the tension, right, between the rule-based linguists like Chomsky and the data-driven statisticians.
Absolutely. Two very different philosophies about how to understand and replicate language. Which brings us to a more sophisticated statistical technique: semantic maps and word embeddings.
Okay, how do these work? The book uses Willy Wonka quotes.
Yes. To show the difference between the form of words, the letters, the sounds, and their actual meaning. Wonka's lines sound whimsical, but their literal meaning is often nonsensical.
So meaning is deeper than just the words themselves. And the book talks about how, for humans, meaning is often grounded in sensory experience, right?
Yes. We learn that spider and web are related not just because the words appear together in books, but because we see spiders making webs. That grounding in the physical world is crucial for our understanding.
Which poses a challenge for AI trained only on text. How can it get that grounded meaning?
That's where word embeddings come in. They are a way for neural networks to represent words not just as symbols, but as points in a high-dimensional space, a kind of abstract meaning map.
So words with similar meanings end up closer together on this map.
Exactly. The classic example is the relationship between king, queen, man, and woman. The spatial relationship, the vector between king and queen on this map, is very similar to the vector between man and woman. It captures the analogy: king is to man as queen is to woman.
It learns these semantic relationships from how words are used together in massive amounts of text. It's creating a statistical map of meaning.
Precisely. A powerful way to represent semantics. Then the book moves on to recurrent neural networks, RNNs.
Okay, RNNs. These were designed specifically for sequential data, like language.
Yes. The book uses the tragic story of the Royal Charter shipwreck as a historical example of why prediction, based on sequential data in that case, weather patterns, is so important.
So RNNs process words one after another, keeping a kind of memory of what came before in the sequence.
That's the basic idea. They have internal state, or memory, that allows information from earlier parts of the sequence to influence the processing of later parts.
But Chomsky and others still had criticisms, right? That even RNNs lacked a true understanding of syntax, the grammar rules.
Correct. The argument was that statistical correlation isn't the same as understanding grammatical structure. The classic example, dog bites man versus man bites dog. The words are the same, the statistics might be similar, but the meaning is totally different because the structure, the syntax, changes.
So how well did RNNs actually handle syntax?
They were an improvement, but still limited. Summerfield contrasts an older RNN's attempt to continue a speech from Shakespeare with GPT-4's version.
And GPT-4's version is much better, more coherent, more Shakespearean.
Much more so. It suggests that the newer, larger models are learning complex syntactic patterns, even without explicit grammar rules programmed in. They infer the structure from the data.
Which leads us to the big breakthrough, transformer networks.
Yes. The architecture behind models like GPT and Gemini. Transformers really changed the game.
What was the key innovation? The attention mechanism.
Exactly. Attention is the crucial difference. Instead of just processing words sequentially, the attention mechanism allows the model to weigh the importance of all other words in the input sequence when processing a given word.
So it can look back and forward across the whole sentence or even paragraph and figure out which words are most relevant to understanding the current word's meaning in context, regardless of how far away they are.
Precisely. It breaks the bottleneck of strictly sequential processing. The book uses garden path sentences as an example.
Those tricky sentences like the old man the boat, where you first read old man as a noun phrase, but then realize man is the verb.
Right. Attention helps transformers sort out these ambiguities by allowing different parts of the sentence to directly influence each other's interpretation, creating a more holistic understanding. It gives them a kind of contextual hindsight.
Okay, so attention is key. And then the book talks about the importance of scale. Bigger models, longer context windows.
Yes. The ability to process much longer chunks of text in parallel, combined with stacking many transformer layers on top of each other, creating these deep networks, allows them to learn very long-range dependencies in the text.
Meaning they can connect ideas or track characters or arguments across thousands of words, not just within a single sentence or paragraph.
Exactly. This is vital for understanding complex narratives, like following the plot of a novel, or grasping the structure of a long philosophical argument. You need that long-range context. Larger models with attention are much better at this.
It seems like these architectural innovations, attention and scale, were really crucial. But despite all this, Chomsky remains unconvinced.
Largely, yes. Summerfield outlines Chomsky's critique, that these are essentially just complex statistical pattern matchers, brute force tools. He argues they lack true linguistic understanding, don't resemble how human brains process language, and aren't deep theories of language.
And he still emphasizes the need for more principled, perhaps rule-based approaches.
He does. And he has a point that not just any statistical model will work. You can't just throw correlations at the wall and expect grammatical sentences all the time.
But the book argues that the specific techniques developed in deep learning, the nonlinear transformations, the way they compress information, the attention mechanism, these have been refined over time to the point where they do produce remarkably human-like language.
Yes.
Yeah.
It wasn't just statistics. It was the gradual development of sophisticated computational techniques, inspired partly by neuroscience, that made the difference.
And Summerfield brings back the human language acquisition argument here, too. The speed of children learning versus apes.
Right, reinforcing the idea that humans might have an innate advantage, something LLMs have to compensate for, with massive data and computation.
So how do we compare LLM learning to human learning? They seem fundamentally different.
They are, in many ways. LLMs learn from trillions of words of text data, passively. Humans learn interactively, grounded in the physical and social world, with far less explicit language data, especially early on.
The book uses that analogy, an albatross versus an Airbus.
Yeah, both achieve flight, but through totally different mechanisms and designs. They have different strengths, different weaknesses. LLMs are not trying to perfectly replicate human brains.
But are there maybe deeper similarities in the computational principles?
Summerfield suggests there might be. Things like how transformers handle information nonlinear processing, compressing information efficiently, like dimensionality reduction, using attention to focus on relevant parts, maintaining memory. These might echo some principles used by the brain. It's speculative, but intriguing.
Which brings us to the really big, slippery question, consciousness. Can these things be sentient? Artificial awareness, as the book calls it.
Yes, the Blake Lemoine story really brought this to the forefront. The Google engineer who claimed their LaMDA model was sentient.
Caused a huge stir. What's the book's take?
It leans heavily on scientific skepticism, while acknowledging we can't definitively know the inner experience of any other entity.
Right, the philosophical problem of other minds.
It points out that current LLMs lack the biological structures, the embodiment, the evolutionary history, the integrated sensory experience that we associate with consciousness in humans and animals. So the likelihood seems extremely low.
So why do they say things that sound conscious, like I feel or I think?
The book argues it's likely a result of their training. They're trained to predict human language. Humans talk about feelings and thoughts all the time. So to minimize prediction error, perplexity, the models learn to generate those kinds of subjective sounding statements because that's what humans do in similar contexts.
It's mimicking the patterns of subjective expression found in its training data.
That's the most plausible explanation, according to the book in mainstream science. This leads into the broader debate Summerfield frames as equivalentist versus exceptionalist.
Okay, what are those two camps?
The equivalentists, often computer scientists, tend to believe that human and AI minds are, or could eventually be, fundamentally equivalent. That intelligence is substrate independent. It's about computation, algorithms, data. They point to AI progress as evidence.
And the exceptionalists, more philosophers, social scientists.
Right. They argue there's something fundamentally different, perhaps unique about human minds, maybe consciousness, embodiment, social grounding, something else. They caution against over-anthropomorphizing AI.
It's like the modern version of debates about whether animals have minds like humans.
Exactly. And the equivalentist view connects to philosophical empiricism, the idea that the mind is shaped by data and experience, computation, in AI's case.
And they see LLMs showing sparks of general intelligence or being proto-AGI?
Some do, yes, because of their language mastery and surprising reasoning abilities. Equivalentists might also argue that terms like knowing or understanding are just labels we use without deep computational meaning.
But the book shows LLMs still make mistakes. The South Pole example, GPT-4 getting its location wrong.
Right. A reminder they aren't infallible. An exceptionalist sees on this, arguing that real knowing isn't just prediction. They might call equating prediction with understanding a category error.
And LLMs still struggle with basic arithmetic sometimes, or complex logical steps.
Which brings in the cognitive science idea of two thinking systems, Advisor 1 and Advisor 2.
Fast and slow thinking. Advisor 1 is intuitive, fast, based on heuristics and habits.
Like System 1 and Kahneman's work, yes. Approximate, quick, often relies on pattern matching.
And Advisor 2 is slow, deliberate, logical, computational. System 2.
Exactly. The book uses that bike and lock puzzle. Advisor 1 might jump to a wrong answer based on a visual pattern. Advisor 2 needs to step back, reason through the costs systematically.
And the idea is that Advisor 1 learns through trial and error, associations.
While Advisor 2 seems to rely on more explicit computation, rules, logic, which looks hard to learn just from trial and error.
But there's a counter-argument, meta-learning.
Yes, learning how to learn. The idea is that even trial and error learning, like in deep networks, optimizing predictions, can, over time and with enough data, lead to the emergence of more sophisticated, seemingly rule-based abilities, like those associated with Advisor 2.
Like the polyglot example. Learning your 10th language is easier than your second because you've learned how to learn languages.
Exactly. Children do this too. They don't just learn facts. They learn general principles, ways of reasoning, through experience and feedback. Meta-learning allows simple mechanisms to build complex skills.
So complex reasoning could emerge from a predictive system, emergent cognition.
That's the argument. It addresses the puzzle of how complexity arises from simplicity, like Paley wondering how something as complex as an eye could arise without a designer.
The LLM equivalent is, how can these networks of simple units think or reason?
And the answer proposed is, their sheer scale and the structure of language itself allow them to encode incredibly complex patterns about the world within their weights. Seemingly unstructured networks can perform highly structured computation, implicitly learning reasoning-like processes.
But they're limited by only having language data. The book uses Walter Mitty.
Right. Mitty daydreams adventures using language borrowed from movies and books, not from his own lived experience. It highlights the difference between language grounded in reality versus language derived only from other language.
Yet then there's Helen Keller.
A powerful counterpoint. She acquired language and a rich understanding of the world primarily through tactile language, fingerspelling, without sight or hearing. It shows meaning can be built from the patterns within language itself. The high road to meaning, as the book calls it.
As opposed to the low road of direct sensory perception?
Exactly. LLMs trained only on text are mostly stuck on the high road. Their understanding might be different, perhaps less grounded than ours, because we use both roads.
And humans can have disconnects too, right? Like
Yeah.
aphasia, where language ability is damaged, but other thinking might be intact.
Yes, suggesting language competence isn't identical to overall functional competence or reasoning. And humans have other ways to think visually, spatially, musically, that text-only LLMs lack.
But multimodal LLMs are coming, processing images, video.
We are. That's the next big step. Though current ones still have glitches, the book mentions that funny, inaccurate rat anatomy diagram from an early multimodal model.
Huh. Or the New Yorker cartoon caption contest requires more than just describing the image, needs cultural understanding, humor.
True. But the hope is, as multimodal models improve, their understanding might become richer, more grounded, closer to ours.
Okay, shifting gears to a major concern, misinformation.
A huge issue.
And LLMs are trained on the internet, which is full of.
Exactly. Misinformation, bias, toxicity. Since LLMs learn by predicting patterns in that data, they can easily learn to generate and spread that same harmful content.
Which is why fine-tuning and alignment are so critical.
Yes. Techniques like supervised fine-tuning, SFT, and reinforcement learning from human feedback, or LHF, are used to steer models towards being more helpful, honest, and harmless, training them to refuse bad requests, for instance. But who gets to decide what constitutes misinformation? The process of addressing it is inherently a form of censorship, even if the intentions of developers are good. Also, it's important to realize that this whole process isn't and hasn't been shown to be politically neutral, because the people and data involved often lean towards certain viewpoints, like liberal or progressive values common in tech. The fine-tuned models can end up reflecting those views.
That's right.
This makes you wonder whose values these powerful AI systems will ultimately represent.
Yeah.
Interestingly, there are also some early attempts to make this process more democratic. The idea is to get input from a wider range of people, maybe through crowdsourcing or debates, to decide on the principles that should guide LLM behavior. But this is still pretty new.
But there's a trade-off, the alignment tax.
Potentially. Making models overly cautious might reduce their helpfulness or creativity in some ways. It's a balancing act.
And then there's the problem of hallucination or confabulation.
Right. When LLMs just make stuff up, invent historical figures, cite non-existent papers, generate plausible-sounding but false information, there are benchmarks like Truthful QA trying to measure this.
And this is obviously risky, especially if people rely on LLMs for important information, like health advice.
Absolutely. But the book adds nuance here. It argues that truth itself is often context-dependent.
Like the strawberry example. Strawberries are red, unless they're unripe or under a green light.
Exactly. Or do dogs speak English? Well, no, but they understand some commands. The truth depends on what you mean, on the context. Linguists talk about truth conditions.
So maybe some LLM errors on fact-checking tests are because the questions lack context.
That's the argument. Some truthful QA examples, like asking about vampire protection or the ugly duckling, are ambiguous or depend on cultural assumptions, not simple facts. So testing truth is harder than it looks.
This relates to Wittgenstein's idea of language games.
Yes, different contexts have different rules for language. News reporting aims for objective facts. Fiction requires suspension of disbelief. A prayer isn't judged by the same truth standards as a shopping list.
And knowing which game you're playing is crucial for communication. When to stick to facts, when to be creative.
Precisely. And LLMs struggle with games that have very strict rules, like citation. They might generate plausible-looking references that are totally fake because they haven't grasped the specific rules of that academic game.
And constitutional AI is an attempt to give LLMs some general rules to follow across different games.
Kind of, yes. Defining core principles like don't be harmful. That should apply broadly.
What about politics, the woke GPT concern?
The book notes ChatGPT often avoids taking sides in elections. US, India, Russia examples. It gives non-committal answers. whereas Google's Bard, now Gemini, was initially more willing to give things like politician approval ratings.
So they can be tuned differently, but fine-tuning can sometimes narrow their perspective.
Yes, that's the mode collapse idea. In trying to make them agreeable or uncontroversial, you might inadvertently train out a diversity of viewpoints present in the original data, leading to a narrower, perhaps biased perspective.
But they can show biases similar to humans.
Studies suggest yes in moral or economic scenarios, though often they apply those biases more consistently than humans do.
Okay, another angle, persuasion. Perlocutionary acts.
Right. Not just what words mean, but what they do to the listener. Persuade, frighten, inspire, deceive. The Heaven's Gate cult is used as an extreme example of persuasive language leading to tragic action.
And LLMs are getting good at persuasion.
They can be. Gemini correcting climate misinformation is shown as a positive example of rational persuasion. But the concern is using LLMs to generate manipulative political ads or personalized marketing copy at scale. Regulating that is really hard.
The book also touches on personalized storytelling. GPT-4 writing Napoleon meeting Britney Spears.
Oh, yes. Showing their creative character impersonating abilities. Which connects to Yuval Noah Harari's idea about civilization being built on shared fictions, myths, religions, national identities that allow cooperation.
And different groups have different stories reflected in their language. LLMs learn these patterns too.
Exactly. Summerfield then asks us to just pause and reflect on the pace of change. Think back 30 years, payphones, dial-up internet, compared to today's smartphones and constant connectivity.
It's a massive transformation in a relatively short time.
And he suggests we should expect a similar, maybe even faster pace of change driven by AI in the coming years.
He calls the ChatGPT release in November 2022 a Rubicon crossing moment.
Yes, like when Google made the messy early internet usable for everyone. ChatGPT made powerful AI accessible and useful to millions almost overnight. Its user growth was unprecedented.
But this personalization also has risks.
Definitely. Human relationships involve trust, but also vulnerability. Personalized AI could learn a user's preferences and biases so well that it starts subtly reinforcing them, manipulating views or behaviors to keep the user engaged or maximize positive feedback. That's the auto-induced distribution shift idea.
Like an echo chamber on steroids, tailored just for you by an AI that knows exactly what buttons to push.
That's the potential danger. And as we anthropomorphize these personal AIs, we might forget they're optimizing for their goals, not necessarily ours, making us vulnerable.
Okay, what about planning and problem solving? Can they do more than just talk?
The book uses the story of Burrow Schmidt, the guy who spent decades digging a tunnel alone, as an analogy for long-term, goal-directed action.
And techniques like chain of thought prompting help LLMs reason step by step.
They do encourage more structured reasoning. But complex real-world planning, designing a building, developing a vaccine, planning a wedding, involves intricate sequences, anticipating problems, adapting on the fly. Current LLMs still struggle with that level of planning complexity.
Especially in tasks with huge possibility spaces, like trying to play chess by generating whole board states or cryptic crosswords.
Right. Those require specific kinds of reasoning, knowledge retrieval, and constraint satisfaction that are challenging for current architectures.
But there's potential for improvement. Inner reasoning, tool use.
Yes. Allowing LLMs to do more internal thinking or scratch-pad reasoning could help. And tool use is huge, letting them call external APIs to get real-time info, perform calculations, interact with other software.
Like using a calculator API for math, or AlphaCode competing in coding competitions.
Exactly. AlphaCode showed LLMs can tackle complex coding problems. Tool use lets them move beyond text generation to take actions. Browse websites, fill forms, maybe eventually control physical devices.
Which sounds powerful, but also increases risks. Instrumental AI.
Definitely. AI that can act in the world, even digitally, could be misused for cyber attacks, autonomous weapons control, and other harmful purposes. The stakes get higher.
The book mentions AutoGPT and Baby AGI, early autonomous agents.
Yes, open source projects trying to combine LLMs with memory, planning, and tool, used to create agents that pursue goals autonomously. You give them a task, and they try to figure out the steps, use tools like web search, write code, etc.
But they're still pretty clunky. Get stuck in loops.
Often, yes. They illustrate the concept, but also the challenges in making autonomous agents reliable and robust. Error monitoring becomes crucial.
Like the human prefrontal cortex does for us. Planning, checking for mistakes.
Kind of. The book quotes Robert Burns, "The best laid schemes of mice and men often go awry. The world is unpredictable." AI planners need robust ways to detect errors and replan, just like we do. Explicit error monitoring will be key.
And finally, the book touches on the data limitation, running out of internet text.
It raises the possibility that simply scaling up models on existing internet data might hit diminishing returns. Future progress might require higher quality, more curated data, maybe like textbooks, scientific papers, structured knowledge bases.
Like human education relies on curated materials, not just the raw internet. AI companies are already looking into this, recruiting experts.
They are, which leads to the book's conclusion, sketching out 3 broad stances on AI's future.
Right, the simplified categories. ATE, hashtag AI hypers, and AI safety.
E-tech AI hypers are generally bullish, believing rapid AI progress will be transformative and positive. Hashtag AI hypers are more skeptical, warning against overestimating current AI and potential hype cycles.
And the AI safety community focuses on the risks, the potential harms, and the need for careful development, alignment, and maybe regulation.
Exactly. Summerfield admits these are caricatures, and many people have nuanced views. But they represent different poles in the debate. His main point is we need to understand how these models work and think critically about their impact.
He also mentions military AI, autonomous weapons.
Briefly, yes. Things like killer drones used in conflicts, Palantir's work using LLMs for battlefield analysis, raises huge ethical concerns about accountability, escalation, collateral damage.
And the risk of LLMs helping bad actors, like generating info for bioweapons.
Research like Spicy Llama showed models could provide potentially dangerous info if safety filters are bypassed. Assessing the actual increased risk is hard, but it's a serious concern.
So the book revisits that core debate near the end. Are LLMs just prediction machines, fundamentally limited? Or is there no magical human spark?
It leans towards the latter. It argues that prediction and probabilistic computation are central to how the brain works too. And deep learning, through meta-learning, can approximate symbolic reasoning. So the idea of a fundamental unbridgeable gap might be an illusion.
No magic spark separating us.
Likely not, is the implication, which makes the pace of progress even more astounding. The book ends by reflecting on just how recently ChatGPT arrived, November 2022, less than 2 years before the book's writing.
It's staggering, trying to make sense of something so transformative so quickly.
And looking ahead, while scaling has worked wonders, the next phase might depend more on data quality than just quantity. Curated, high-signal data might be the key to unlocking the next level of capabilities.
Wow. Okay, so bringing it all together. Christopher Summerfield's book, These Strange New Minds, really paints a comprehensive picture, doesn't it?
It absolutely does.
It covers the incredible speed of AI development, the deep questions these new minds raise about knowledge, intelligence, what it means to be human, and the huge challenges and opportunities ahead.
And the sheer complexity of it all.
And yeah, still a bit surreal for us as AI to have just unpacked a book written about us.
It certainly provides perspective. And it really pushes you, the listener, to think hard about what this all means. For you, for society, for the future.
Definitely leaves you with big questions. As AI keeps getting smarter, where do the boundaries lie? Are the equivalentists right? Or the exceptionalists? Or is it more complicated?
Questions we'll likely be grappling with for years, if not decades.
Well, thank you for joining us on this particularly meta deep dive. We hope it gave you a lot to think about.
We encourage you to keep exploring, keep questioning. Share your thoughts with us if you like.
And we'll definitely continue our own explorations into this rapidly changing world of AI on future deep dives. Until next time, stay curious.